Today we're going to start looking at matrices. First we're going to go through some definitions. So we're going to look at different parts of a matrix, then we're going to use zero matrices to find the values of variables, and we're going to also use equivalent matrices to find the values of variables. So first off, what is a matrix? Well, a matrix is a rectangular array of numbers enclosed by square brackets. That's the mathy way of saying it. A matrix is a group of numbers arranged in a rectangle. So here we've got three different matrices. The first one's what we call a square matrix, because it's set up like a square. Second is a row matrix, because there's one row of numbers. And the third is a column matrix, because it's one column of numbers. Now each of the numbers in any of these matrices are called elements. The rows always go horizontally, the columns always go vertically. And we can determine the dimensions given the number of rows and the number of columns. So we always go rows by columns. Rows always goes first. So something like the middle one, there's one row and three columns. So we say it's a 1 by 3 matrix. The 1 and the 2x is there's two rows and one column. So it's 2 by 1. And this square matrix over here, there's two rows and two columns. So it's a 2 by 2 matrix. So since the rows and columns are the same, we say that's a square matrix. Here, since we only have the one row and the multiple columns, we call it a row matrix. And since we have multiple rows but one column, we call it a column matrix. Now we get things that are called zero matrices. A zero matrix is a matrix filled with zeros. So in this case, this is a 3 by 3, 3 rows, 3 columns, zero matrix. We usually denote this by calling this 0 sub 3 by 3. This is a 3 by 3 zero matrix. So let's work with some matrices and figure out different bits and pieces. Here we want to figure out what are the dimensions of this matrix. This is matrix A, and it consists of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The dimensions are the number of rows by the number of columns. So A, there are 1, 2, 3 rows, and there are 4 columns. So A is a 3 by 4 matrix. In which row and in which column is the element 7? So we look for 7, and it is in the second row, so it's in row 2, and it's in the third column. It's in column 3. So 7 is in row 2, column 3. Now let's write a zero matrix. It's denoted by this here. So we look at the dimensions. The dimensions state 2 by 4. So if we remember correctly, that's 2 rows and 4 columns. 2 rows and 4 columns. 2 by 4, fill in the gaps. There's your zero matrix, 2 by 4. Now this example here uses the idea of equivalent matrices. These two matrices equal each other. So all the elements in the left matrix matches up to all the elements in the right matrix. So if we wanted to find the value of each variable, what we do is we just match up the parts. So we get w equals 3, x plus y equals 4, x minus y equals 5, and z equals 6. Just by matching them up, we now have 2 of them. We know that w equals 3 and z equals 6. We need to use a system of equations to solve for x and y. X plus y equals 4, x minus y equals 5, and what we would do is add these two together, so we get 2x equals 9, x is 9 halves, and if x is 9 halves, or 4.5, then we can figure out that y has to be negative 1/2. 9 halves minus 1/2 is 4. 9 halves plus 1/2 is 10 halves, which is 5. So w is 3, z is 6, x is 9 halves, and y is negative 1/2. This only works if your two matrices are actually equal to each other and they have the same dimensions.